So Satya, thank you for being here at PyCon Colombia 2018.
Thank you so much for inviting. It's a beautiful city and beautiful conference, very well organized, and people are really warm. Food is great, so I really enjoyed my stay here.
So the first question is related to the invitation to PyCon Colombia. What motivated you to come here?
So the first thing was that I had never been in South America. So one thing I wanted to visit, South America and see the country. But it is also about, I wanted to see, so when we are in the United States, you think that English is the only medium of instruction because that's kind of become a default, right? But there are a whole bunch of people around the world who do not have that facility in English. They need help in other languages. So I wanted to see for myself how is development being stopped by this language barrier.
Yeah.
So I wanted to see how many people can producing content in, say, Spanish help people in Colombia and in Latin America. So I wanted to see it for myself. And of course, the venue is great, so that was an attraction as well.
Okay. So you have a strong background in computer vision. You are really popular because of your blog, learnopencv.com. But first, could you please tell us how did you end up doing computer vision?
Yeah, so during my undergrad, I was looking at some image processing projects as an undergrad, and I talked to one of my seniors. So I think it was summer of 1998 or 1999, where during summer I just stayed back at the university to do some projects. And there was another senior who was doing some work. And I said that's a very cool image processing project. He said, it is computer vision. And I said, what is computer vision? That sounds very cool, right? And he said that when you try to make machines see like humans, it is computer vision, it is not image processing. So I thought about it, like when I went back and I thought about it, it sounded very exciting that you're trying to make robots see, right? The next day I asked him, you're applying for grad school. What do I need to do to apply for grad school in computer vision? And he gave me all kinds of information. This school is good, that school is good, etc. But then in the end he said, there's just one problem. And I said, what is it? You will not find a job in computer after doing a PhD in computer vision. So that's how I got interested, and I just ignored the last part. I said, okay, who knows? At least if you're doing a PhD, it has to be something very interesting. That's how I got into the field. And in 2001, I came to do my PhD at University of California, San Diego.
Okay.
And I did my PhD under Professor David Kriegman. And so I got exposed to a whole bunch of different areas. So the nice thing about Professor David Kriegman is that he always had funding. So, so never had to worry about funding. So we had to do a few things for the funding project. But apart from that, you could do anything you want. So you could choose any project you want. And I was working simultaneously on two different projects. One was in cryo-electron microscopy.
Okay.
And the other one was core computer vision. I wanted to work on things where some basic assumptions in computer vision are violated. Like one of the basic assumptions in computer vision is that everything is Lambertian. Light reflects equally in all directions.
Okay.
But my PhD was analyzing things where there is glass on the floor. Light is not reflected equally in all directions. So in those situations, we work. So there was these two things that I was working on, and this cryo-electron microscopy, I thought, there are 50 people in this world who do this kind of thing. This thing has no future, so I did not work on it. And it turns out that this year, the Nobel Prize in Chemistry went to the guy, one of the top three people in cryo-electron microscopy.
Yeah.
They received the Nobel Prize in Chemistry, solving similar problems. I mean, they were senior, much senior to me. Their work is much substantial than what I was trying to do. But the field that I had dismissed, that
Okay.
there's no future in this, 3 people from that field got a Nobel Prize this year. So yeah, so that's how I got started, and then in 2007 I started my own company with my PhD advisor. He took time off, and later, so we ran that company for 8 years.
Mhm.
It's still around. I just stepped down as the CTO because 8 years was a long time.
Yeah.
And then I started my own company, Big Vision LLC, which is a consulting company.
And which projects do you usually do for consulting in Big Vision LLC?
Yeah, so there is such a wide variety of projects. I was surprised myself. So when I was doing my PhD, I used to think that, computer vision means, you could do face recognition, you could do some object detection, etc. But the variety of projects that we undertake in our consulting work, that is just mind-boggling. So I'll give you some examples. Recently, we did a project for a company that analyzes horse feces, so the
Okay.
stool of horse, to analyze bacteria in it. So they analyze different kinds of bacteria and figure out whether the horse is sick or not. So we do object detection on it and also classification. Now, not only is that, so that is one extreme. On the other extreme, we try to detect fakes in ID cards. So if you have an ID card, you take a picture of it, you manipulate some fields of the ID card, we are automatically able to recognize that these fields were manipulated. The picture was changed and things like that. And then we also work in the fashion industry, where we try to detect whether some merchandise is fake or not.
Okay.
So there is a huge range of projects that we have worked on. Not only that, there are so this was, one is fashion, security, and then we did object detection for people, but it was not really object detector. It was intrusion detection. When somebody's trying to break the system, somebody's trying to climb a wall by crawling, they're crawling towards the wall, you have to detect all those kinds of events. So that's another example. And then there are some, fun application projects where things like cosmetic surgery, people are trying to use stuff. And then we also work with a medical device company that tries to figure out the lens power, the power of your lens, by putting a device and a phone right next to the eye. So they and then they shoot some IR rays, and they find out the curvature of the lens, and they are able to predict.
Okay.
So we developed several algorithms for that. So you can see that there is a huge variety of things.
And what do you see about the evolution of the field of computer vision? Because you have told us previously that 10 years ago it was hard to find a job for a computer vision person that whose research was about vision.
Right.
So what do you think about finding a job in computer vision is happening right now?
Now it is just, the field has taken off in a very big way. If you are a computer vision researcher now and in the right spot, like in the Bay Area, then jobs are, you keep getting poached by big companies. So suppose you're working for a big company, another big company would say that, I'm going to give you 20-30% raise and just join us. So there is a huge demand for computer vision and machine learning people, and there is not enough talent pool yet. So that's why you also see this emergence of online courses. Universities will take a long time to produce those graduates necessary for the next, necessary to fill this gap. So online courses have taken their place right now because there is this knowledge gap. People who are, let's say, a Python programmer with adequate amount of training, they can enter the field, and that's why online courses help them do that. And they are trying to fill the gap that way, while universities are catching up because they are more formal, so they are catching up, kind of.
So this was your first motivation to create your blog, your online course about OpenCV for Faces, or did you have any other
So I've been always interested in teaching. When I started my blog, the whole point was to teach people. And the reason was that when you teach people, so I'm a practitioner, we do consulting work, but I also, when you teach people, you have a much deeper understanding of things. because you cannot sweep things under the rug. People are going to ask questions. It's a very public forum. So you have the things that you don't quite understand, you have to dig deep and perfectly understand that.
Yeah.
So that was the motivation for creating the blog. And once the blog was created, I launched the course 2 years after the blog was created. And all through this time, I was getting constant requests from people who wanted to say, if you create a course, we are going to join you. So please, I would love to see a course. So there was such a demand that I decided that I enjoy doing it. Why not start it? So that was the motivation.
And what do you like advise, or what is your advice related to people which is entering to the computer vision area of
Right.
research?
So one thing, so computer vision is pretty vast. There is machine learning, AI, computer vision, but beyond that, beyond machine learning, there is a lot of computer vision outside of that also. For example, and a lot of people do not know that. People think that object detection and image classification is computer vision.
Yeah.
But if you just open, like if I pull my phone out, look at all the different computer vision things that are happening to just get the phone out. It uses face recognition to let me in.
Yeah.
So that is not only that, it is using 3D shape estimation based on dot patterns, and that is also computer vision. If you're using fingerprints, that's computer vision. Once you get into the camera app, open the camera, they have all kinds of filtering based on faces and other things. All that is also computer vision, but it's not machine learning. Not necessarily machine learning. Parts of it is machine learning, okay, and the other part is not. And similarly, panoramas, that's also computer vision, right? When you pick out your Amazon app, they have this scanner which can scan an object, not just barcode scanner, but it can look at an object and say what it is, and you can order. So in a single device, you can see there are so many different applications. So my advice is that when you look at this field of computer vision, yes, machine learning is great, but there are also other things beyond computer vision, beyond machine learning, that are part of computer vision. So you should not ignore those. So the whole field of AR, for example, augmented reality, has a huge computer vision component. You need to be able to analyze. You need to be able to say that this is a flat floor and I can place an object on it, right? So you can say half of AR is computer vision.
Yeah.
So that's one advice, that don't just look at the machine learning aspect of it. It is much bigger than machine learning. Like Google Street View,
Yeah.
that's also computer vision.
Like panorama stitching.
Yeah.
Okay.
So, and there are a whole bunch of problems in medicine and other fields where computer vision is used. So if you're entering this field, the very first thing to keep in mind is that computer vision itself is pretty new. I mean, and for example, deep learning is also very new, like 5 years of when it shot into fame. A lot of research has been done before, but let's say if you read 100 papers on deep learning, you can be an expert. And 100 papers is not a long time. We are talking about in 6 months, you can start from zero to very respectable expertise in the field. So keep that in mind. And I also want, like, people who are starting out. So this advice is very general advice,
Yeah.
not related to machine learning or computer vision in general. It is, you have to use your time. People complain that they don't have the time. So they have to use their time as they use money. So any time you're putting your time away for something, it is either an investment or it is an expense. So if you are spending your time reading the news, which has no consequence on your life,
Yeah.
that is an expense. But if you're spending that time reading a paper or doing some, trying out a framework or something, that's an investment in your future. So that people forget. A lot of people say, oh, how can you write this blog and still have a consulting business? And I tell them that I wake up at 4 a.m. every day. And they say, oh, that's crazy, that's too hard. And I said, that's not hard, it's just inconvenient, right? It is hard, like, let's say what is hard? The things Suppose you are a kid in Africa, you don't have electricity and you're trying to learn something, that is hard.
Yeah.
But waking up at 4 a.m., it's just inconvenient, right? And you start doing it, it's not hard, it's just inconvenient. So to know the difference between all the advantages you have and focus on your advantages, somebody who is able to come to PyCon Colombia, they have a lot of advantages in life which a lot of other people don't have. So focus on those advantages, make the best out of what you have without focusing on things that you don't have. Don't focus on your disadvantages, focus on your advantages and push hard on it.
So what are your thoughts about the future of computer vision? Because right now it's deep learning, mixture of deep learning and computer vision.
Yeah.
So what are your thoughts about the future of computer vision?
So first of all, right now deep learning is really hot and it works really exceptionally well, right? But that doesn't mean that this is the end technology. This is the technology which is going to take us to the very end. Every 10 years, we have new set of tools, new set of technologies that come up and wipe out everything that was done before. Like right before deep learning, support vector machine were very popular. With you could use it with any kind of feature like Hog, and that was like the standard way of doing object detection. And now deep learning is the standard way of doing it. But to think that that's the end is not right. Things will evolve, new technologies, new ways of thinking will come up, and they will wipe out these things, and then you'll have to graduate to that new technology. And the second thing is that it's not just deep learning like I was explaining. There are several other applications of computer vision that have nothing to do with even machine learning. So the future is bright. I mean, if you think about it, even now, right from the beginning when a child is born, a camera is used to monitor the child, whether they are awake or not. Suppose the mom is cooking food or something and not available, they put a baby cam right next to the baby to see whether the baby is awake or not, right? Not only that, baby cams are also, they can monitor heart rate, etc., to make sure that they're fine. And cameras are everywhere. So in the future, I see drones with cameras being very important inspection tools. So think about drones with cameras. They can inspect crops, so they can be used in agriculture, windmills, etc. This is a real project that somebody had brought to me. It is very difficult to inspect windmills for damages. So you can fly a drone and try to find all the places where the windmill is damaged or not, right? And you could also monitor traffic in real time using drones with a camera. And that's just one application. Now, until now, we have also been collecting a lot of visual data, like surveillance cameras, etc. They have been constantly recording all these things without any analysis. What the world will move to is real-time analytics. So real-time monitoring of surveillance cameras, where you maybe just counting people, or you could be doing some security applications, because visual data is available. It was also available before, but now we have the resources and the compute power and the technology to actually use it. So it's really bright, and it's not. You'd be surprised by the number of applications that we will see in the future.
One important application that appeared last year's conference, CPR, was face-to-face. People are not right now worried about if this is going to take a wrong direction or not, because it is applied generally to fake news.
Right.
So what are your thoughts about this?
So any technology which is as powerful as AI, it has the potential of misuse. And it's very difficult to stop people from not using it in a bad way at all. It is just that you have to be one step ahead of the people who are going to misuse it. Like if you think about the internet, it has enabled so many good things, but at the same time, it can enable terrorists to communicate better among themselves, right? The same technology, it can be used for promoting fake news, for example. So technology will be misused, that is for sure. and people will come up with new technologies to prevent that from happening. But there are so many good things that can happen from the rise of AI that we almost have to bear it as an expense. Like if you think about old technologies like a knife, it's there in every house. It can be used for murder, but most people use it for cutting vegetables. So that's
okay. Well, you have a blog, learnopencv.com.
Yeah.
So I'm curious, because in every blog post you post code in both C++ and Python languages.
Yeah.
Because this is the Python conference. Why do you post the write code in both languages?
Right. So when I write code for OpenCV, I write it for both Python and C++. There are some places where I don't write, like if I am writing a TensorFlow or Keras post, then I don't worry about C++. And the reason is that the application domain.
Okay.
So in a lot of places, OpenCV is used in embedded systems and all those devices where you have to move to C++ or sometimes even C for squeezing out the most most performance.
Yeah.
But in a lot of cases, it doesn't matter. Writing in Python is just fine because ultimately it is C++ in the backend. The compiled code is C++. The library was built using C++, but there is still a small performance hit that is taken. And the thing is that people are coming into OpenCV from from many different areas. Some are using C++, some are using Python. I just wanted to make sure that I'm catering to all those people because once you write the code in one language, it doesn't take a long time to convert it, especially in OpenCV, from one language to the other. So that's why not have both. And people who are Python programmers, sometimes they may have to use C++ in their application. You cannot be always tied to, oh, I only do Python. So think about yourself as engineers and all these things available to you as tools, right? You cannot say, I just do only deep learning, right? I'm not going to use any other tool. I don't use C++ because I'm a Python programmer. Think about yourself as a solution provider, right? You are an engineer, your job is to provide solution. The client comes in and asks for a solution. You find the best solution that will work for them, not what is most convenient for you. So when you see code in both C++ and Python, if you don't know one of the languages, then you can refer, oh, I know this language, so I can go to that point and see, oh, this is how it is done in C++. Now I'm more comfortable with. So people, by comparing the two implementations, people can understand the other language better.
And how did the blog start? What was your motivation to start the Learn OpenCV blog?
So the motivation was, first of all, I wanted to try out this aspect of teaching. For my own understanding also, I wanted to learn by teaching. That was one motivation. The other motivation was that the company that I had founded, it was not doing very good. I mean, we had a great run. We at one point, we were very profitable and things were going great. But by 2015, things were not looking very good. And I was starting to think that, okay, I'll step down at some point. And then the question was, what do I do next? So the blog was a way to have a footing in the not just consulting, to have my word, have my personal brand built. And that's very important these days. If you have a personal brand, you're not tied to a company to give you a salary, right? So you can build your own stuff around a personal brand. And it served all those purposes. I was interested in teaching. I could build a personal brand. And the blog would have, even if suppose I had decided to go back to the industry, work for a big company like Facebook or Google, even then having a blog and having that content out there would be a good thing. They would see that, oh, I have been writing code. They could look at my code and analyze it. The way I explain it, they would know how I think. So that's all a positive thing. And in today's world, it becomes almost necessary if you don't want to be, I mean, not everybody can get a great a college degree, right? Some people may not have, you cannot always go to Stanford to get a great degree, right? So what do you do in that case? Well, you could build a personal brand by doing things in public. So you practice in public. If you write code, put it on GitHub and let people comment on it. Write a blog, make videos about the stuff you're doing. This way, you can have an exposure, you can have an audience without needing, a big university to certify that you're good.
Yeah.
But at the same time, you also have to be very careful about the quality of your work. And I recently read this book called So Good They Can't Ignore You. And that's the philosophy people should have. Be so good that other people cannot ignore you.
Okay.
And when you put out stuff in public, it forces you to be better than what you are, because it's embarrassing to put out stuff in public. So when you practice in public, it is a bit scary because everybody gets to look at all the mistakes you're making. And it forces you to be a better coder, be a better writer. It helps that.
Okay, so I think we are finished, and thank you, Satya, for this interview, and enjoy the rest of the conference.
Thank you so much for the invitation. It has been really great.
Okay.
Thanks.
Thanks.